explicit in those decades. And I think for me, the most remarkable revelation of the problem probably occurred in the world of artificial intelligence. I learned about this when I was studying models of cognitive processes that were initially generated by Russian investigators like Sokolov and Vinogradova, who were very well-known names in the Russian neuropsychological literature, which is a very academically impressive literature. They were students of Luria. I think both Vinogradova and Sokolov were students of Luria, who was perhaps the greatest neuropsychologist of the mid part of the 20th century. They were convinced to some degree that we built internal models of the world and then compared what was going on in the world to those models. Sokolov discovered a phenomenon called the orienting reflex, which was an electrophysiological response to error detection, or a response to novelty. That's another way of thinking about it. And he should have won a Nobel Prize for that, because discovering the instinctual basis of the response to novelty, that's no small thing. There's a lot of novelty in the world. And Sokolov really mapped that, in some sense, mapped that onto the body and onto the nervous system in a way that superseded what philosophers had done before that, because it made it much more concrete and tied it down to the underlying neural architecture. And so, for example, if you're walking down the road and there's a loud noise behind you, and the noise is of indeterminate meaning, so perhaps a car has jumped a curb, that's a possibility. You'll go like that and stop and turn and orient towards the place in the space-time continuum where your stereo vision has localized the noise. And you do that really without thinking. I would say it's an act that occurs outside the domain of free will. And the reason you do that is because you might die if something unexpected happens, right? Something that's outside your framework of expectation. Now, you know your framework of expectation. You're an ignorant creature. You don't know everything. You don't even know that much. And your representation of the world is actually rather shallow and low resolution. It's good enough to get you where you want to go most of the time. But sometimes it isn't, and sometimes it's error-ridden enough, given the circumstances of time and place, that the error will kill you. And so you're equipped with instinctual mechanisms that orient you towards the source of the revelation of your ignorance. And that's something very interesting to contemplate, I would say, physiologically and neurophysiologically, but also philosophically, and I would also say to some degree theologically, right? That you have an instinct that orients you to the source of your ignorance. And you better have an instinct like that, because there may be a shortage of knowledge, but there's no shortage of ignorance. And that's, part of the problem of the relationship between the finite and the infinite, right? I mean, we're finite creatures. We can't know everything. We can't even know as much as we need to know. And that means, in some sense, we have to be able to deal with the fact that we don't know enough. And one of what Sokolov outlined, at least in part, was the underlying neurophysiological mechanisms that made this orienting reflex possible. One way you can measure it, for example, is if you put a gadget, a galvanometer, on someone's finger, and you play them a sequence of tones, when you play them the first tone, they'll show quite a response, and then the second tone lesser, and after that lesser, until finally it'll flatline. And people thought about that as habituation, but the more sophisticated cognitive scientists regarded it as the building of an internal model of the stimulus in all its variety of parameters. Interesting word, stimulus. We'll return to that. And then if you play someone a different tone after habituating them to that sequence, the electrophysiological response will reinstantiate itself. Or even if you alter the spacing between the tones, the same thing will happen. And that's all part of this response to novelty and then the mapping of novel territory. This is unbelievably important, this discovery, because you don't learn anything except by encountering it as novelty first. So it's fundamentally the initial processes of everything you do to learn everything there is to learn everywhere all the time. And so, like I said, he should have won a Nobel Prize, but people really didn't understand the fundamental significance of this discovery. And a very influential line of English, British neuropsychology emerged out of that, because a gentleman named Jeffrey Gray, who was the most outstanding student, I would say, of Hans Eysenck, who was the most cited psychologist, research psychologist in the world for pretty much the last half of the 20th century. Jeffrey Gray wrote an incredibly brilliant book called The Neuropsychology of Anxiety, where he integrated the work the Russians had done, which very few people knew about, apart from Gray, who read absolutely everything. The Neuropsychology of Anxiety, I think, cited 1,300 deep scientific papers, neurophysiological papers, animal behavioral papers, like hardcore psychology, because there is such a thing. And he actually read all those papers, and he actually understood them. And then he integrated that with Norbert Weiner's, who was one of the fathers of cybernetics and computer science. He integrated that with Norbert Weiner's cybernetic theory and with, well, a raft of animal experimental material, and laid out the neurological basis for the establishment of the orienting reflex and also for the establishment of memory itself. It's a tour de force, that book. It was written in 1982, and psychologists have really only begun to digest the material in that book. So I read it when I was, well, back in about 1982, very soon. That was 85, I guess. Very soon after it was published. It took me like 6 months to read it because, well, I had to learn animal physiology and neuropsychopharmacology and animal behavioral science and cybernetic theory, and just along the way to understand what he was talking about. You know, it's a profound work of philosophy, I would say, and it's probably a necessary work of modern philosophy because we're starting to understand the underlying physiological substructure of many of the processes that have been discussed in the philosophical realm for forever. And so, okay, so what does this have to do with this problem? Well, back to the AI researchers. So, stemming from Sokolov's work, at least in part, was the idea that there's the world out there, and it's made out of objects, and they're sort of self-evident, and what we do is we build an internal model of that world, and then we compute trajectories, we make maps, we compute trajectories, we lay out plans that constitute a manipulation of that internal representation, and then we act out the representation. And it's kind of an empirical idea, philosophically speaking, and the idea is that sense data is in some sense given to us, and from that sense data, that given self-evident sense data, we build these models, and then that's how we think, and that's how we operate in the world. And everyone, that's kind of folk psychology. Everybody thinks, well, that's right. That's how it is. It's no, it's not right at all. And that's why we don't have general purpose robots. Because what happened to the AI researchers was that they tried to build machines and built toy environments. So imagine you're trying to build a basic robot, at least initially. You can't model the whole world, so you build toy environments that the AI system can model, and then you have it do simple things in the toy environment. You couldn't even get the machines to see the toy environments, and part of what was discovered in AI was there were no toy environments. Well, imagine even if you just have a simple environment that's made out of pyramids and columns, spheres, just simple geometric forms. Well, you still have the problem of variant lighting. It's like, well, is a pyramid in the morning the same as a pyramid at midday? Well, what about 5 minutes past midday? Or 30 seconds past midday? Like, how much lighting, how much illumination change is necessary before the object isn't the same object? Well, maybe illumination doesn't have anything to do with the object. Well, that's kind of awkward because then you don't get to see it. And how is it that we manage to infer the stability of an object across transformations of illumination? And the answer is, we don't know. And how is it that we're able to perceive objects at all? Because the other thing that became complicated, and you see this if you ever use a program like Photoshop, you know, you can see objects in a photo in Photoshop, and the objects appear self-evident. They have boundaries and borders, but if you zoom in, you can't tell where the boundaries are. They fade into all the other images that are behind or ahead or wherever they happen to be displayed. And then, well, the image is quite different if it's black and white, and then you can highlight the colors and expand them. And so there's an endless number of things you can do with the single image of anything. Well, you think about what that means. There's an endless number of things you can do with a single image of anything. Well, how in the world is perception possible then? And the answer is, we didn't know. Well, at the same time, approximately the same time, the same problem emerged in literary criticism. And you can see why in some sense, right? If you can't perceive something even simple in some canonical manner that's self-evident, how in the world can you derive a single reliable canonical interpretation of a given text? And then you could multiply that problem. You say, well, it's bad enough for a single text, or maybe a single paragraph, or even a sentence, because sentences are amenable to multiple interpretations, and complex sentences in the beginning are susceptible to an endless number of interpretations. Really? Endless? Well, endless is a problem, right? Because to perceive something, there has to be an end. So endless is a real problem. And the cognitive psychologist, Medin and Aguilar, who worked at MIT, they said a finite number of objects can be grouped in a near infinite number of ways. Well, you think, well, imagine your books on a bookshelf. Well, you have the books, and then you have the sequence of books. You think that's all self-evident. Well, how are you going to arrange those books? Well, that's a problem if you've ever tried to sort out your library. And if it's a big library, it's a big problem, right? You have to invent a very complex and sophisticated indexing system to know where the books are. Well, the books on your shelf, you think, well, come on, really, there's not a near infinite number of ways to arrange them. What are you talking about? And that's only the axiomatic that's the axiomatic structure of your a priori perceptions manifesting itself as self-evident fact to your ignorant mind. Because that claim is actually wrong. So you might say, well, color, thickness, density, age. How about thickness of paper? How about the thickness of the spot exactly half an inch below the 35th page in the 3rd chapter? And you think, well, that's a stupid way of organizing your books. And I would say, well, how do you know it's stupid? Exactly. And not sort of. Right? Because you can't just claim self-evidence in this situation, because the self-evidence of the stupidity of that categorical structure is actually the mystery. And it's the mystery that, say, postmodernists encountered when they were trying to specify the canonical meaning of a text. Just a single text, a single paragraph, a single sentence. There's a multiplicity of potential interpretations. Even worse, there's a multiplicity of potentially valid interpretations. And so how do you do anything but throw up your hands and say, well, there is no solution to that problem. Or at least, and this would be better, we have no idea how we solve this problem. And what would even be better would be we have no idea how we solved it in the past. And say that's particularly germane when you think not even necessarily so much about the interpretation of a given text, let's say the Bible, to take a complex problem, but the canon of texts itself. Now the canon of texts, the fact that there's a canon of texts, roughly speaking, we have agreed in the past to some degree on the boundaries of that category, although there's plenty of cognitive activity around the edges trying to decide what would fit in and what wouldn't, which is exactly what happened, for example, when people were trying to aggregate the biblical corpus across time, because the Bible is, of course, a library of books. What's in and what's out? Why is it in? Why is it out? Well, the answer to how we answer that is we don't know how we answer that. And there's this process of deliberation, let's say, that is part and parcel of the process that gives rise to the aggregation of a library of texts into a corpus. But we don't really understand the mechanism. We don't understand the mechanism at all. And that's actually all fine, except that we don't have general purpose robots yet, although they probably are more or less around the corner in about 5 years, partly because the AI researchers solved this problem, and part of the way they solved it was by embodying cognition, incarnating artificial intelligence in an embodied structure. And the first people to really propose that that was absolutely necessary, I don't necessarily know the first people, but I know that an MIT researcher named Rodney Brooks, who, by the way, invented the Roomba. Some of you may have a Roomba. And it's kind of a laughable little object, but not really, because it can sort of move around your house without falling down the stairs. And your 2-year-old can't do that, so the Roomba isn't nothing, right? And Brooks was one of the first people who really recognized that to solve the problem of perception, we would have to duplicate the process of evolution in hardware. And so he started building these little machines that pretty much all they did to begin with was scoot away from light. And, well, eventually that became the Roomba, which is a pretty useful gadget. And you see variants in some sense of what he's done with self-driving cars, because they're embodied systems as well, right? Because the car is actually a body that moves from place to place. And it turns out that a lot of our perceptions require embodiment, and it turns out that one of the philosophical consequences, implications of that is that the way we solved the problem of perception was through 3.5 billion years or thereabouts of evolution. And also that there was no other way of possibly solving it. And so that's a testimony to the power of evolutionary thinking, I would say, but even more a testimony to the power of the process of evolutionary development. And you might think that that reduces human cognition to something sterile and mechanistic, because many of the proponents of the notion of natural selection have adopted a fairly reductive materialism to account for the process of natural selection. And we're going to talk about that a little bit tonight too, I hope, if I can manage to tie all these